Geophysical archaeological prospection permits the discovery, investigation, mapping, and documentation of buried archaeological remains without disturbing them. Such surveys are repeatable. In contrast, any archaeological excavation can only be conducted once. The most commonly used geophysical archaeological prospection method is magnetometry. By deploying an array of sensors in combination with global satellite positioning systems, it is possible to render the surveys more efficient, mapping along these virtual lines. The introduction of motorized multi-channel magnetometer prospection systems over the past 10 years has rendered this approach highly efficient, permitting the mapping of areas measuring square kilometers rather than square meters or hectares. Penetrating radar measurements permit the three-dimensional imaging of structures in the subsurface. However, single-channel instruments are painstakingly inefficient when it comes to the investigation of entire archaeological sites. Using multiple georadar antenna and smart data positioning solutions can improve the situation, as shown with this three-channel system with 25 centimeter horizontal antenna spacing. Such a georadar system is looking approximately 1.5 meters into the ground. The real game changer was the introduction of large antenna arrays, as this Swedish system consisting of 16 georadar channels with only 8 centimeter horizontal crossline spacing, permitting the collection of very dense datasets. While our knowledge, the use of the georadar method is non-destructive when it comes to the buried archaeological remains, we are not traceless, as you can see in this English lawn pattern as a result of the blanket coverage. Regarding imaging resolution, we are now able to map the buried remains of these Viking Age burial mounds. In the left one, you can see the 2-meter long and 80 centimeter wide coffin with differently reflecting and absorbing features inside. We have looked similar to this 3D model of a body and grave goods in a wooden coffin. Currently, research aims to increase the imaging resolution of the method further, using high-frequency georadar systems, permitting more reliable data interpretations. A novel step to high-resolution archaeological prospection will be the combination of the subsurface georadar data with 3D recordings of the surface. As here in Pompeii, first tests of surface and subsurface mapping have recently been conducted. Using image-based 3D modeling and a large number of photos, it is possible to detect feature points, here in the top left shown, which are densified to a dense point cloud, top right, and a 3D surface model, bottom left, that can be converted into a textured photorealistic surface model. The same approach for efficient high-resolution geophysical archaeological prospection can be applied to the exploration and investigation of underwater archaeological heritage. This survey boat has been equipped with side-scan sonar, multi-beam sonar, and sediment sonar systems. Multi-beam sonar scans a fan of 1024 beams simultaneously, revealing the water depth in great detail, as well as any objects on the water bottom, such as this wreck of a car in Lake Mondsee, which is a Citroën traction avant in circa 8-meter depth. Scan sonar imaging provides the highest imaging resolution, and here we can see the rear of the same car, as well as fish in the water column and other objects on the soft lake bottom. Greatest archaeological interest in the upper Austrian lakes are not car or boat wrecks, but the remains of the pile-dwelling culture in Lake Mondsee, Lake Attersee, as well as Lake Keutschach in Carinthia. Partly, the 5,500-year-old wooden piles are still visible in the shallow water. Traditionally, these pile-dwelling sites with many piles and logs have been mapped using divers and manual survey with a tachymeter, resulting in maps like this one. Underwater excavations are very time-consuming and spatially highly restricted. Using a sediment sonar, we can explore the lake bottom. This sediment sonar profile shows the lake floor as well as the reflections of the wooden piles in the water. Using an innovative 4-channel sediment sonar, it is possible to efficiently record high-resolution 3D data volumes. Data volume can be cut into horizontal depth slices showing structures within the sediment. Here we can bring for the first time structure into the large number of wooden posts present at Station See in Lake Mondsee by being able to image 3 rows of post holes of a large pile-dwelling building. Using the latest geophysical prospection technology, we are able to explore and map archaeological sites on land as well as underwater in unprecedented resolution and efficiency. Over the course of few weeks, 13 square kilometers of bathymetry of Lake Mondsee have been mapped. Next will be Lake Attersee with 24 square kilometers and 20 pile-dwelling sites. The bottom of lakes, streams, rivers and seas are among the last white spots on Earth. By exploring what is lying beneath the surface, we can discover scientifically valuable traces of past cultures, but as well structures of geological, sedimentological and limnological interest. Unless we have a look, we will not know what is out there. Thank you.